This is how autonomous cars are working because it can do, as it trains itself using a back proposition algorithm or some other algorithm to train itself, discriminate between good data and bad data, or discern between good data and bad data. We were doing generative AI at the time. And when you look at generative AI...
Hey, Janet, how are you doing?
I'm doing great. Thank you.
I'm going to introduce you here. So this is Janet George. She's done many things in her career, but currently she's the CVP, Data Center and Artificial Intelligence at Intel. She also works with GM Cloud Enterprise, which is also attached to AI, and Security Solutions Group. So if anybody you know currently, she's busier than all of them combined. So thank you for giving us your time. Thanks for coming on and talking to us.
Thank you.
So very quickly, just so for people to familiarize themselves with you, what would you say is your sort of your day-to-day? What do you feel like you do on a daily basis?
Yeah, on a daily basis, I'm in a very operational role. I'm in a very implementation role. So, managerial aspects of my day-to-day implementation with customer engagements and customer products. AI is my strength. It's my background. I spent 2 decades in AI, but I think we sit at the intersection of many things, right? So we sit at the intersection of cloud, we sit at the intersection of AI, we sit at the intersection of data, and we sit at the intersection of silicon. All of these things have to come together for us to be able to get the true outcomes that we want. So I feel like infrastructure is a big stool of the leg, but there's also 2 other stools, right? There's the outcomes with AI and all of the tooling, and then there's also the outcomes with data. So the combination of it really makes it very interesting.
I think this might be an obvious question to you, but for people who are not really sure, how exactly does AI interact with data? Where do you see that relationship, especially for someone who's working so low at the tiers, because there's hardware, software, but how do you see data from a hardware point of view? So in terms of the challenges there and all that.
Yeah. So without going into deep depth in AI, let's talk about autoencoder or neural networks, right? These are things that can take and reconstruct data, whatever form or shape input data is being given to them. And then it can train itself. And as it trains itself using a back proposition algorithm or some other algorithm to train itself, then it's able to come back and start doing predictions. There is the traditional AI, which does all kinds of predictions. We have naive Bayes, or we have, random forest, decision trees, different kinds of AI algorithms. And then you have the more newer ones. And the newer ones are really what the rage is all about now, which is large language models and generative AI. So really underpinning all of this is really the size of data. So if you say you have really small data and you don't need to train, then AI is questionable. I mean, do you really want to do AI to get outcomes you're after? You can do a fairly good sized query and you can build a robust search engine to pretty much get what you're searching for. But if you really want to train and scale and learn on new data on a continuous basis, then you do need AI algorithms or AI incorporated into the backbone of everything you're doing.
Right. So data is important, and AI allows you essentially to massage the data and get the outcomes you want very quickly because there's a lot going on. So, and on the sort of hardware side, because a lot of people talk about software, as they should, because it is really quite a revolution in software, because essentially it's these like you talked about, these models and these algorithms sort of being bunched together, k-means, like you talked about, backpropagation. But at the end of the day, it exists on a physical system. So how does that, is there something that people have to or should be aware of when dealing with the hardware? Something that's been already in the news a lot, obviously, is NVIDIA and some of the challenges that they're facing from a supply chain point of view, which is a good problem for any company to have, but it's definitely is still a problem when we're talking about these technologies. So what's your perspective on that? What do you see about that?
Yeah, so from a hardware perspective, if you think about a layman, right, or anybody who's doing any kind of build out AI on hardware systems or silicon, for them, ultimately what matters is the workload. And ultimately what matters is the performance of that workload. So let's say you're working with AI workloads, or you're working with search workloads, or any kind of workloads that is related, edge workloads and so on. You want to see the performance, and the performance has to translate from the silicon all the way through the software stack up to the application layer, where you're actually seeing real time that performance. And so if you can't unlock the performance from the silicon, then you will notice your training taking a long time. You will notice that your data sets are just spinning for a long time. Like early on in my career, I spent a lot of time looking at these, I was doing compilers. And so as I switched from compilers, in the early days, compiling took so much time. You would set the compiler on, you'd get 2 cups of coffee, you'd be sitting around until you waited and the compiler really finished, right? And so you say, oh my gosh, the compilers are like, interpreters are better, right? Because interpreters will quickly give you the response the minute you type in what is it that you're trying to look to get interpreted. In the early stages of AI training, it's something similar, right? People would train with large data sets, and my team and I would be waiting around for these training sets to finish. And sometimes if the training is done on the cloud, you're looking at 12 hours of training, depending on the size of the data, right? So you set off the training modules and then you go off and you come back the next day. Now, we've come a long way from that. We can train much faster in a couple of hours, and again, depending on the data set. So it's really important to have data sets that are highly cleansed, less noisy data sets, and data sets that have annotations with them and metadata associated with these data sets. So you don't have these autoencoders, trying to denoise the data, right? So when the autoencoders are trying to denoise the data, especially corrupted data, then you're looking at very long performance times on top of the fairly silicon performance, if you will. So what NVIDIA, Intel, many of these companies are doing are really working to translate that performance all the way from the chip through the software stack. And so we have to touch the Linux kernel and go all the way up from the Linux kernel to the algorithms, the actual neural networks that are performing all of this work. And that's the connection between silicon software and ultimately AI that sits on top doing all the training, all the way up and down the stack.
What is the fundamental, and correct me if this is the wrong question, but what is the fundamental, I want to say algorithm or optimization that this Linux kernel now has to cope with? So with a shallow understanding, there is a lot of linear algebra calculations that need to be made, and happenstantially, that's why NVIDIA was sort of entered or was able to become important in the market, and they sort of switched towards that. But it's not instinctual to me what and it might be instinctual to others, what the kernel now has to understand.
No, you hit it. You hit it, because that's exactly it. You have to, if you say that you have something in the hardware that is very powerful, and this is where NVIDIA's strength comes and Intel's strength comes, we spend a lot of time trying to make sure that we unlock the value. And think of it as Red Hat too, right? Like Linux distribution or kernel layer sitting on top of the operating system. If you can't actually get that performance benefits, and the performance benefits are by doing mathematical calculations and optimizing these all the way up through the stack. So another way to think about this is also, let's say I'm going to take security, because security is becoming so prominent for us, right? Let's say at the hardware level, you have secure enclaves and things like this, where you can keep the data secure while the data is being transported to a data lake, or while the data is being cross-application data. And many of AI is about looking at data between applications. When a traditional enterprise is actually doing data manipulation, the data is stuck in Salesforce.com. It's probably stuck in HCM tools. At least it's the case when you're working with an enterprise data, and you're trying to find nuggets. Like if you're doing vendor performance management predictions, you're trying to look at data between the CRM, and you're trying to look at data between HCM to really start to predict how these vendor performance looks like.
What are HCMs very quickly, just to make sure that...
HR systems, right? So if you have, your recruitment systems or your HR systems, or you've logged on, interactions with your customer and so on and so forth, you want to look at all of these before you look at trying to predict the performance of the vendor, or vendor management systems and scoring the vendor, ranking the vendor, trying to figure out all of the details, confidence levels with particular vendor performance, and so on. So now you're looking at data being transported from multiple legacy systems that are sitting in an enterprise. And as you transport this data, this is where the data hijack happens. And this is where the data gets proliferated out of the enterprise, right? These are all I call vulnerable spots for the data. So when you enter these vulnerable spots, you want to make sure there's some kind of security. And then these are built into the silicon. So you have the silicon, what I call secure enclave. So when you transport the data is actually sitting inside a secure enclave, and the next data is coming into or is operating in another secure enclave. And the transportation and the protocols between the two secure enclaves are very much validated and attested, right? So it's qualified. And so you can't have hijacking happen. But if you have all these capabilities at the hardware level and you're not seeing that penetrate or propagate through the software layer, then you're not going to actually use any of that, right? And so the whole goal is to make sure that what needs to be done. And then so we sit and try to do security at the higher levels of the stack, right? So you can do security at the software layers of the stack, but it doesn't compensate for what you can do at the silicon layer. One of the advantages with CUDA or any other software system is really about this optimization all the way from the silicon to the top. Now, that involves not just the Linux kernel, but it also involves other things like optimization of Kafka, optimization of Python, optimization of libraries. So optimization does not stick at one level, but it's very layered. So it goes all the way up the stack, right? And as you know, you're looking at Kubernetes orchestration and all of these different levels of orchestration because of the layering that we have, business logic versus middleware versus, application layer and algorithms. So ultimately, AI is very much sitting at the top, right? AI is not at the middle layer of the stack. It's these algorithms, TensorFlow, Python, they're all sitting on the top. And so unless you see that value come up, you're going to have to make adjustments for it at the algorithm level, right? So how do you protect at the algorithm level? It's more difficult to protect at the algorithm level. It's easier to take foundational capabilities and protect yourself at that level.
Right. If you want to do it at the algorithm level, you kind of have to create these pockets. And because you're sort of stacking them, or because just by the very nature things are stacked, the higher you go up the stack, the less speed you have and the more complication there is, because it's just not optimized on a chip level or a pseudo chip level relative to how you want to think about it.
That's exactly right. And one example, I'll just say this example. One example in my tenure with Western Digital, when I served as a chief AI officer, one of the things we saw was we couldn't work with open source TensorFlows, right? Because they were so exposed to critical data being stolen, right? There were so many gaps. And so we had to take all this TensorFlow technology that we saw in open source and augment that with our own technology. So we had to write our own TensorFlow. And people say, why do you want to write your own TensorFlow when there's already TensorFlow out there in open source, right? And you don't. You can use many of the techniques that is in open source, and you can use those as your building blocks and augment with what you need. Because when you think about silicon data or you think about design concepts, these are highly proprietary data. You don't want that data to be exposed either to your competition or to anybody looking to attack that data. So those are the kind of things that you have to then go out and do on your own. Now, if it was already built into the silicon, you could use it. But in Western Digital's case, they were memory providers. So, they were inherently making memory. So all of their footprint was about memory and the data related to that.
So I think just to sort of get people more familiar with you, because one thing is for sure, you've really been able to explain the complexities that you deal with on a day-to-day basis. But as all people who sort of deal with a lot of problems, they always ask themselves how they got here. And so if I ask you the same question, I'd love to know, so how you got into tech and how you got into, these different pieces of technology that honestly were speculative as early as 5-6 years ago. I think people who were in the industry saw it sort of come up slowly. I think the thing that I saw was reimagining of all images as Aaron Cloud's painting us, and that sort of was going around, and it was quite interesting, and people were making pseudo websites on it. And then now it's become this sort of phenomenon. But I'm sure that getting into AI early was not I'm not sure how popular that might have been. And we'd love to see how you got into that and then got into sort of the scaling of these problems and scaling of the power of these problems, and almost like sort of at the most granular level, trying to solve the whole stack in a way, or solve for basically the whole stack.
Yeah. Early on in my, early days of childhood, I was always interested in complexity and complex problems. I naturally, navigated towards complexity and how to solve complex problems. And then also I was very good at math. So, the combination of really being mathematical and also just really looking at complexity in problems. And then, my training was in computer science with artificial intelligence as my thesis topic. So I had picked pretty early on that I wanted to go into artificial intelligence because I was very interested in the whole inferencing model. And at the time, we were just inferencing. It was data sets were so small. We're talking about 20 years ago, right? So data sets were very small. And so you couldn't do very large scale. But if you look at every single algorithm, they've been around for 20 years. You look at random forest and naive Bayes and pick any one of these algorithms, right? These have been around, Markov model, right? Chain model. These have been around for a long time. So it's not like machine learning wasn't around. It was around, and people were studying this for their training and their basis of education. It's only that they couldn't practically make sense of it and use it, right? When I was working at Apple, I spent a lot of time inferencing. And I realized very quickly that the data sets were so small and you couldn't do much with these data sets. And this is why I went into compilers and compiler programming, and I really started going down the path on distributed computing. But very shortly, I remember in Yahoo, we started having eBay actually was the proliferation of data. We had so much data around, and now we had to do searching and crawling on these massive data sizes. And search algorithms were not built to do that. Search algorithms, I call it the retrieval problem versus the extraction problem, right? When you retrieve data, and you're especially retrieving large amounts of data as part of a search problem domain, you're not actually looking at what was retrieved. You're just looking at the information retrieval problem. Now you go into extraction problem. Extraction problem is an AI problem because now you look at the contents of what is retrieved, not just the retrieval and the indexing of very large data sets. World Wide Web created massive amounts of data, and many of this data was just noisy. So search results was not actually, you couldn't say that search results were contextually relevant. PageRank model was inherently about, who viewed the content, right? So it was about wisdom of the clouds. And wisdom of the clouds is great, but then if somebody just liked something for the reasons of humor or other reasons why they liked a particular link or page, it would surface to the top. So we had to lean into extraction and really looking at tokenizing the contents and learning the contents. And so I think I got into from two aspects. One, my own passion, and then the other was my career track record, right? Like I was always attracted and leaning towards the harder problems and the more novel cutting edge things because I was sitting at the precipice of these bigger problems that the world had not solved. eBay was trying to figure out how to do a lot of searching that was valuable for their sellers and their buyers on the marketplace, and the volume that they were seeing was unlike any. Yahoo was dealing with an entire Library of Congress data, you know what I mean? And on the website, it was just amazing amounts of data that we had to literally figure out what to do with it to make it valuable for our customers. And we wanted to bring value. Like if you were on the Yahoo website, we wanted to make sure that you actually saw content that was relevant to the content that you were browsing. We didn't want to show you jiggly ads or things like this, So it made sense to really mine the data for our customers and then start to do early AI and data science. And that's where my career really, the trajectory of AI really took off was in Yahoo. And then from there, it just became more industrial because the world was catching up and people were really trying to figure out AI tooling. And now you can see, I feel like with this newer models, the kids are embracing it much faster. So if you see the kids, they are writing their school papers and they use 5 different large language models to create their school papers. And then pretty soon they make a subset of all of these, right? So the baseline has been established, and the baseline is, hey, there's ChatGPT and other technologies that's out there, they can very robustly inform you about a particular topic, but it's not without human reinforced learning, right? And so human will always have to look at these and say, does this make sense or not, right? You can't completely rely on the machine. So it's very much still human feedback in the loop, and it's augmented by human intelligence.
You sort of talked a little bit about sort of the complexity of this and sort of all the things you need, math, and you were interested in solving hard problems and interested in math. And what that reminds me of is I think when you think about what Turing was doing initially, the first thing he did is he talked about how you would need a lot of in fact, when I read it, he said he would need people who solve problems and a lot of statisticians. And his original problem was but this idea of search and I think search and sort of sorting. He said it was a fundamental abstractions that have to do with intelligence in and of itself. And and obviously going forward and talking about how you need statisticians, and then the book saying that it didn't turn out to be true, and now it is absolutely true. It's basically the fundamental pieces that power everything. So it's always interesting how the idea of you saying that it's something that's been going on for a long time. It's actually been going on since the start of the idea of any sort of Turing machines in general. So I just thought that was interesting. And you spoke a little bit about, and there's several things that you've brought up. One thing that was interesting to me is this idea of security and optimization. You sort of almost interchangeably use it, but in my mind, they were sort of opposing each other in certain ways. And you see how the more boxes you have to put things in, the slower it's going to become, and the slower it becomes, less optimal it becomes. Optimization is usually measured in speed, especially for business. Business is definitely about speed. So could you talk a little bit about those challenges and how, how that sort of manifests itself in your experience, and some of the interesting challenges you're seeing with security and optimization, and how you're sort of managing that and trying to walk that thin line?
Yeah. I wish we could start with brand new data, right? Our problems would all be so much easier because we didn't have to deal with bias or noise or any of this stuff. The world we live in is not perfect, and the data we have is imperfect. And so that's where we start. And so I don't look at AI as revolutionary. I look at AI as evolutionary, right? And so when you are in evolutionary in nature and you have to deal with existing data sets, every enterprise is looking at what existing data sets they have, not just internal to them, but also external to them in terms of their customers, in terms of the websites, in terms of, their partners, what kind of data do they have? So it starts there. And I think as we go through this, as soon as you bring in data, and we saw this early on in Yahoo, it is open, it's wonderful, right? Like when you start dealing with data, and especially when you start bringing many pieces of data together, like the whole concept of data lake, let's bring and unite the data. A data lake has its own trade-offs. Like every technology has its own pros and cons. Yeah, trade-offs. Data lake has its own set of trade-offs. But I think the conversation changes when we when we can have AI really discriminate between good data and bad data, or discern between good data and bad data. Because I think the human brain, if you look at how our human neural networks are made in the brain, we don't go about trying to take out all the noisy data from the world. We don't purify the data, right? We basically know how to differentiate between what is noisy data or what is not good data and what is good data. And we change our focus towards good data. Now, the challenge for this, and this is Google Brain started doing this really well early on, where you saw cat images and you trained on enormous amounts of cat images, and then, deranged cats don't matter because you've already trained on very good cats. And so, authoritative data. And so when you have authoritative data and you have a lot of noisy data,
you're embedding the idea that familiarity breeds contempt.
That's right. So, the neural networks keep up. But when you come into, this is where the security still plays a very important role, because when you come into enterprises, now you're having these neural networks to actually, sorry about that. You have to work with these neural networks to actually worry about figuring out, hey, how do I, as a neural network, try to distinguish between real and fake data? So the role of a discriminator plays a very important part. And these algorithms are not as mature as we want to think it, because even with generative AI, we see a lot of hallucinations, and these hallucinations coming from it trying to create its own data, right, without any human intervention. And we know, all of us know, like if you were to go into a factory, manufacturing especially, there is so much organizational knowledge. There is so much domain knowledge. It almost takes you 2 years to really capture that domain knowledge and get ahead of it, right? So that's sort of trying to figure out how this organizational knowledge within an enterprise can translate, and how do you train networks to understand. I remember spending hours in the factories as I was building practical, AI, to really train the neural networks with very small sets of data. We were doing generative AI at the time, and when you look at generative AI, we were really creating capacitor images with fake and true polarities, right? If the fake polarity was the one that caused all the visual inspections to fail, true polarity was what caused us to succeed. And so we were spending a lot of time training these neural networks. And really, there was so many permutation combinations of how the polarity was put on the physical silicon. Even the experts would have to sit down and debate whether these polarities made sense, or should I'll take the memory channel. So when you send the current from the upper layer to the bottom layer of a NAND chip, 2-dimensional NAND or 3-dimensional NAND, this current creates these memory holes. So these memory holes can look like oval or eclipse based, or somewhat heart shaped or whatever. And we had to figure out, what's the right memory hole look like? What's the right circumference? What's the right radius? How much deviation can it have? All of these things. It required a lot of people who are experts in device physics to come and sit down and decide whether this was right or wrong.
And you were embedding this AI straight into the chip. That was the goal, was to embed the decision making abstraction straight into the chips.
That's right.
All right.
So now we're sitting here saying, hey, but when we do this, and if we do this, like, do we have the domain knowledge and the expertise of the domains built into the training sets and built into the discrimination and encoders and things like this, right? We don't want to sit on the outside and keep on monitoring what AI did. We'd rather have AI do the right thing from the get-go, right? And we score it and weight it and change all of that to make it do the right thing as we learn. So this discrepancy is going to consistently exist, right? Even with web reviews. If somebody rated a web review as number 5, and then within the context of the web review, they said, I'm not going to buy the product. For us humans, we're very quick to hone in on that, right? We say, okay, they're not going to buy the product. So obviously, they were dissatisfied with this product. They gave us a great review because they were kind. And so I think this knowledge is very complex, right? And it has so many different permutations to it. You can see things like a house burned up and a house burnt down. It means the same thing, right? It's just a different way of expressing the same sort of knowledge or information. So I think those are areas where we're going to see AI as it advances trip up quite a bit. Right.
So again, I mean, I think this even the terminology is almost deceiving, because this idea of good insinuates virtue, and at the same time, it could also, in a quantitative science, insinuate some sort of measure being hit at quite precisely to some rounding value, right? So I think there's a lot of space for AI to trip up in that, and I think even when you sort of alluded to this idea of the page rank algorithm, which is basically what initially Google does, it doesn't do that anymore. And sort of how quickly, I think initially whoever was on the internet early on realized not necessarily realized, but saw how useful it was. It really did kind of give you what you asked for. And you had to ask it certain ways maybe, but you're getting the information you want. Now it's something else. Might be more marketing. I think the GIS system has been gamed, which to some degree could be good, could be bad. Obviously, it gives a lot of people opportunity to be able to have their products out there, so it's not necessarily a bad thing. But it's not exactly what people always want from this technology. So this also sort of brings me to, when we talk about gaming algorithms, sort of how people feel about AI. So there's a lot of trepidation, to say the least, about what it can do, what it can't do, what it will do, what it won't do, what it should or shouldn't do as well. So could you talk a little bit about because you're if there's one person who understands the limits of this technology, it's you, because you work at the very physical, at the electron shunting level of it. So could you talk about its limits and sort of what you see it can and can't do? Maybe it's a bit professorial, this request, but it'd be interesting to get any of your points of view on it.
Yeah. I mean, I'm more scared of the people using AI and the people developing AI than AI itself, right? Because I feel like human beings are so capable of, we're capable of distorting, right? So if we are the responsible owners of technology, and we should be the responsible owners of technology, then it is our responsibility to make sure that it is not misused. There are the right regulations and the right policies and all of these things that are put in place, because it's very easy to misuse technology. Right. For example, we can abdicate our own responsibility. There's an AI system over there, right? The AI system said so. So let's all follow the rules and let's just force the rules, right? But what if the rule doesn't make any sense? What if AI made a mistake? What if AI predicted something wrong? Who is going to arbitrate, right? And do we need authoritative person to arbitrate, or can regular person arbitrate? So I worry that the rights of the regular people who don't have power are more going to be at risk, right? Because they are not going to be able to voice themselves authoritatively against policies and systems and processes, while these things have to be put in place. And we have to pay attention to who is putting these things in place and how they're put in place and what is the exception. I think in AI, we would need a lot of exception handling. Just like when we started programming in C and C++, we had a great deal of exception handling, right? And I think we need that before we can say that these systems are really good, because the data we're dealing with is inherently terribly biased. And then people are operating with constraints, and people are operating with the knowledge that they are taught and built upon. So it's very difficult for somebody to break up. We're a system of rules, right? We want to follow rules. These are good things. But if you have the wrong rules in place, and that's why the world is freaking out, right? That's why people are, because there's a genuine concern that AI can be really utilized for non-good. But the technology in itself is somewhat neutral. It is the implementers of these technology and the usage patterns of the technology and power behind the technology that really would make it really bad. So I think if we start small and we say, let's use AI for efficiency reasons and sort of build upon, right? Let's just get efficiencies out of AI rather than having large systems mandate and have a very, very important place in our lives. I think it's important to start small, and it's important to start looking at the value that we get and the efficiencies that we get from these technologies.
But what do you mean by efficiencies? Is it the efficiency with which the technology is able to work, or the efficiency with which it's able to produce results that are, I want to say, virtuous, right? Because once you make decisions, there is a concept of morality that's sort of added there at this level of like pseudo consciousness, right? Because I mean, you can say if L statement can have morality, but not intrinsically. But I think the way that AI is, that it is interacting with a person and making a decision for them. It's kind of how it's being used. So how do you make that happen? I suppose I'm not sure if that's a very well structured question, but it's a very tough thing, right? Because the English language itself it's just by its very nature like abstract. Can you embed that level of abstraction into a chip?
Yeah, it's a very, very difficult question, and it's a very difficult problem. I would sort of move towards enterprises, right? Like, let's start with the efficiencies before we try to make all consumers efficient. Then we go down that path. Let's make enterprises efficient, right? These businesses that are spending so much money in operational cost. And I think today we are still spending, as enterprises, when I talk to customers, all of my customers are spending huge amounts of money in operational cost. Sometimes it's tickets. They receive like 400,000 tickets in an IT department. There's no knowledge base for the employees to go seek and search and get answers. There's no clusters and classifications for their customers. They don't even know which customers are really good, which customers are not so good, and so on and so forth. So I think the efficiency layer is just that's why I think that now the world is basically saying, hey, are you an AI company doing business, or are you a company doing business and then just using AI as a tooling? And I think every company will eventually become an AI company. And that means it will have to embrace AI for its foundational back office, operational reasons, right? And operational reasons, it's just like you need maps. I remember working for a mapping company before, and I was telling people, hey, why do you have static maps on your website? You should have dynamic maps on your website, because people usually have a picture of their location and they just showed you a static map. And now we have a dynamic map. So you can not just click on the picture, you can actually navigate directions and all of those things. In a way, AI is going to go in that level, right? Like, so you're not just going to have inefficiencies in your organization. You need to up level your organization to get efficiencies just from an operational standpoint. Then you go to the next level and you start to provide value to your customers through AI and tools, building out new products. I've been at the other end of the spectrum, so I've actually created revenue through AI, right? So you can have net new revenue streams and you can have net new businesses being created out of being an AI company. But starting off, I think the efficiencies can just be at the enterprise level, really just making sure that your operations are running, your vendor purchases are tracked, your performance reviews are done via some sort of a prediction model. And, you keep track of all of the data and you use the data correctly. I even remember, even with HCM systems like HR systems are so manual today. I mean, if you have two people with the same name, you can't differentiate, right? You need a country manager to say, okay, what's their record and what's this record, and then what kind of name version you need to do in order to pull out their records differently. The older systems are kind of struggling with that still. So there's a lot of opportunity, I think, with AI and efficiencies and cost in business. And I think that's where we have to start. And then the consumer end will continue to grow faster and quicker, like ChatGPTs and others, where people will use some sort of a ChatGPT type model for searching. They would want to know, not just query search and putting it all together. But I was recently sitting with one company that said, let's take ChatGPT and ask ChatGPT how we should compete better. And ChatGPT did a very good job telling them what their weaknesses were in that industry and how they compete better and what their competition is doing. And, for a baseline, I was super impressed, right? And I was sitting with the CEO and all of the group of people, and they said, we didn't know this. There was so much information here that we didn't know. So I think as humans, we are getting to the limits of the amount of information we can pull via search. There's so much information out there, as you know, and as all of us are experiencing. We are under information overload. So in information overload, how do you even pull base information that is relevant to you, that is contextual, that actually provides value, right? We start there. And then we have to put in a lot of regulations in place as we go higher and higher and say, let's go with AI further. Like, this recent case about the lawyers having ChatGPT do the thing, that's just over the top, right? Like we should not be going there. That is far on the other side. Right? I think we have a lot of crawling to do and we have a lot of efficiencies to get. But that said, I think on the enterprise side, on the government side, we are seeing a lot of adoption, and that's primarily because people are saying, hey, given that we saw how text has changed our lives, right? Now anymore, you don't write a very long email if you just want to put in 2 sentences.
Emails
right?
have become texts, actually. If you write an email the way you used to, you can be considered a Luddite or someone who wants to waste someone else's time.
That's right. And so just imagine the next level where you have assistant-based technology, right? It's not even text. It's just like you're saying, hey, I'm thinking of David and I want to give him this text. And then it automatically says, David, Janet's trying to text you and get hold of you or your time. And that's the thing, right? Like one less typing, one less, whatever, right? Like one less bit of your time, because it's all measured in time. So I think those are where the technologies will go, where you will get assistance, pull out my favorite, whatever, look at my email that I wrote from like 2 months ago, pull that out. So search will really go to the next level, in my opinion, right? And this is why I think Microsoft with Copilot has really made a big statement, right? And so we can see like even programming, when you see like these newer technologies of AI, they're getting through computer science course very well, right? And you say, wow, did it study the whole coursework in such a short period of time? And it got a 4.0 GPA score or 3.9 GPA score. That's like very good, right? And so Yeah, it's very, very good. So if these technologies, and that's what we are seeing the power of these technologies, and the power of the technologies frightening us. Instead, I think we should really look at the power of the technology and say, we have such a powerful technology, how can we try to be more efficient? What is open to being less manual? So I think automation, we'll see automation, really cognitive automation, really take off in the next years as companies realize the amazing potential. Kids have really figured that out. They're like, I'm not writing a paper from scratch. I'm already going to get a lot of data using ChatGPT about this particular topic, whatever, right? Whether it's gun control or whatever control it is that they want to learn about the topic, submit a paper, or they have something really passionate about, they're going to use some sort of, and calendaring. Like these are things like I've noticed like how well ChatGPT can do planning and calendaring and managing of tasks and letting you know like this task is here and there. So, those are all early things that you'd be like, wow, my life is never going to be the same with Alexa,
Hi.
right? Alexa came about, and then you could do so much things, even just pulling out your music that you like and asking Alexa a lot of things that you would normally have to go do.
It makes traffic much less of a chore than it used to for a lot of people.
That's right. That's amazing. Yeah, you're not wasting time, and that's what happens when you have information overload. Everybody's pulling for your time, and you are pulling for your own time. So then these efficiencies matter because it gives you relief.
So I think, and just to summarize what you said, I think the best example is when you talked about how companies, the searching in a company for someone's name is a complex issue. Something as simple as that. If you have the same name, who are you really? And then this, getting that identity of a person, of a company of 4,000 or 5,000 people, there's quite a few John Smiths, and having someone make that decision for you, or having an AI really get that information for you, can save you a lot of time, because it's too simple a question for you to have to call 5 or 6 people in an organization. So I think that's a very powerful idea.
Yeah. Also think like in the database world, we had this whole problem of deduplication, right? Like it's showing up over and over again, and you're like, is it the same J. Lee that I'm talking to? Is it a different J. Lee? Is it middle name? There's H in the middle. What's going on, right? And now and context, like which department are they? What are they working on? Is it the same person I've interacted with? Is it a different person?
Right, exactly. Yeah. No, even so it's interesting. The Israeli security sort of force had a company that came out of it, and essentially their way of identifying people is how many dimensions of information exist, and that sort of defines sort of authenticity. So a person who isn't a person who doesn't have a nefarious intention has quite a few breadcrumbs of their identity existing all over the place. And a person that does have a nefarious intention has maybe 1 or 2 threads. And if you look at it as a database table, it's just how many columns does this ID have? And it's sort of the same. If you have too many columns, you might need someone to go look at that. That's sort of what's popping up in my head when you talk about identifying individuals. So I have someone just run all the columns in a row and find out sort of who it is, or how many dimensions of a person can an AI identify, and then that tells you who they are, and then you can really ask that question. And when we talk about AI in this way, and we talk about it helping us make these kind of decisions, all these sort of this is a very simple example. It's great, but as you sort of scale up that decision matrix, there's 2 things, and I think this sort of exemplifies a lot of people's concerns, and it'd be interesting to hear your point of view on it. Is as we offload these decisions and we codify them. So you initially gave the example of you have this hardware that you have to kind of have a lot of experts decide what you encode as the actual decision that's going to be made. As we stack these decisions, first of all, if we get one wrong, what happens? And the second thing is how a company is reacting to an environment. When the environment changes, the company becomes obsolete. How does a company deal with that reality? Especially with something like hardware. I mean, it's depending. This also depends on the company, but hardware is quite concrete in its outcomes and exists in places for quite long periods of time. And software, you can kind of change it, right? That's almost software and software engineering space is software is defined by kind of its velocity of change. So can you talk to a little bit about that and how organizations now have to see themselves now and see? I'm sure there's going to be an emergent organizational behavior in terms of how they see how things happen. I'm not sure if I'm trying to construct this question as well as I can, but it is like a whole new. If AI is the center, it's really about managing the AI in a way that it reacts to the market and the sort of knowing how many decision layers deep is it that you have to go extract something if you want to change it, right?
AI, I mean, you said it, like Chris, the AI is a massive disruptor, right? It's going to change a lot of things, and especially when it crosses the tipping point. So now the silicon chips that you develop for AI have to look very different from the silicon chips that you develop for CPU and for x86, right? It cannot be the same chip just because the artifacts that is required for compilation versus the artifacts that are required for training are completely different, right? So how you compiled a set of code or how you compiled programs are very different from training, where there's no compilation required, but it's a learning system, right? And so the chip that does programming is not the same chip that could do well with training and learning, right? And so you're looking at fundamental changes. That on top of the fact that you have very strong abstraction layers that you have to work through, right? Because the silicon is at the very bottom. And then you have all these different layers that you have to orchestrate and work through. So abstraction is going to be another factor. Then it is the whole cloud. Like when you think about cloud, like it's similar to the internet, right? You're using the cloud, but yet you don't know that you are so far away from your physical machine. You're really in a data center in a cloud that you are using all of the ecosystems that come with that cloud. So, that level of abstraction where everything is pooled, memory is pooled, storage is pooled, compute is pooled, and you're working with fleets, and these fleets load balancers can move the fleet off to any sort of configuration that they would choose. They can even, predict which workload should work on which hardware and so on and so forth. All of these things become very big challenges for hardware, becomes very big challenges for silicon, right? Because as you think about it, the control is lost, where we had very tight coupling between what was run on the silicon from the whole software stack, x86. If you look at it was so tightly coupled, you almost knew what outcome you were getting and what you needed to build. Now it's so loosely coupled, and it is so mix and match, and it's such an abstraction layer. So you're going to rely very heavily on the APIs that you have, or you're going to rely very heavily on the standards that you put in place, and so on and so forth. So with AI, now most of the CSPs and Intel, we're all building AI chips, right? They're going to go look different from your regular chips, just because the game is different. You're looking at different types of clusters, and you often talk about the parameter space, right? Somewhere I published these parameter spaces, and we've gone from millions of parameters to billions of parameters, and now we're dealing with trillions of parameters, right? Well, where are we going to end up with this parameter space? Just the space and scale of parameters, right? How are we going to tackle that? Can our traditional silicon, can our traditional chips help us with this parameter space, right? And eventually, we would have to keep up with the knowledge of the world. We can't come back and keep on cutting down the knowledge of the world and cleaning it into small little snippets, right? So I see that the conversation changes when AI can deal with the noise and the signal on its own. So if AI can sit at the edge of data and start to assign, and it's doing that very well. This is how autonomous cars are working, because it can do that discernment of world data very well, right? Because world data is authoritative, there's encyclopedias on it, and it can learn. But when we get in language, this language has all of these tokens that is already around for many. I mean, of course, the connotations we still have to understand, and accents and cultures, and the inner meaning of language, and different languages add more complexity to that.
And piping in the information about how the language changes and what meanings are, jargon, slang, those different kinds of world data, perfect physical world data, and the data that we care about usually seemingly is this, 7th-tier layer on top, which is human generated information. But please go ahead.
think also about natural language intelligence, right? Like there's so much intelligence built into the way we speak and the tone and the context of it, and even expressions that come through in these languages. So we're nowhere close on that, but we are getting there. But
Funny enough, the internet that made it change faster, because they cascades throughout the world even faster than it used to. So these iteration cycles or these change cycles are happening more frequently. A person 2 years younger than you can speak in a way completely different because there's something that proliferated that you don't recognize. Yeah.
So now you turn it around to the enterprises, and enterprises are the oldest change. They are, they have so much history and so much traditions. It's difficult for them to pivot and change, but they have to keep up with the change that is occurring in the consumption world, right? And so as enterprises look to follow the consumption world, and as they look to cater and help the consumption world, you remember the time when we never allowed texting and social media in enterprises. And now social media and texting is part of an enterprise, right? Because the enterprise has figured out that is part of the world. We cannot keep it out. We have to bring it in. And similarly, we will see that in the intelligence models, the knowledge models will have to get better. And this is where I think the conversation in language will change, when we can take all of the enterprise data and not have to spend so much time on data quality and noise and encoders and decoders, and really trying to build out these discriminators and focus more on trying to figure out, hey, how do I look at cross data sets, like data sets that have completely different formats and schemas, and can these schemas and formats evolve over time? What is the bias in the data set, and how do we even tag these biases, right? Like how do we put an give us an understanding of this bias, and where do we build the semantics, the way we represent these data sets? Like how are the semantics going to be built? What features do we extract or don't extract? Like today we are all extracting a lot of features, but can we live without extracting the features and just focus on the signals? And is that enough focus to just, like the human brain, just focus on what matters and focus on the signals and build from there? But I think this whole generative AI has so much promise. And the promise is because it can create new data sets. And so if AI can create data sets, powerful data sets, that is, again, human augmented or human helped by human, then I think we are on to something very big, right? Now we look at factories, we look at these enormous production sites, we look at trying to look at operational things like GE equipment and manufacturing and whatnot, different industries, even life sciences industries, where you're discovering cancer or drug or looking at structural biology. These are areas where now generative AI can take the knowledge of a human, replicate the knowledge. And that was the power I saw with generative AI in the factories, where generative AI quickly took what belonged to a few elite set of domain experts, device physicists, scientists that studied this day in and day out. It took that knowledge or that base data set and replicated massive amounts of failure data or massive amounts of disk capacitor data that was then used to train, right? So now you're creating the data that you need to train. So you're creating the right data to train it on, and then you're using the same data to then do the predictions, right? So that sort of shift, when that happens with generative AI, we are on the precipice of something very huge, something massive, right? Because now we can go into our factories and we can look at all of the archaic ways of doing things and really add what I call super productivity to enterprise.
So one thing I'd love to ask is, as technical as we've been and as granular as you have been, you are sort of at a different tier of your organization as the CPP. So you have to take all this and then also sort of be a leader and translate this in more languages than most people are probably used to, and not necessarily non-English languages, but ways of understanding. And then you also lead a team, obviously, and probably multiple teams. So it'd be great to get your understanding on leadership, especially in technology, and sort of how you've seen that it not only evolve, but what it's going to be now and what it's going to need to be. And it'd be interesting to see, because you probably, especially in the AI space, so what is it, how are you presenting ideas to people and framing things so that they can, they are sort of in an environment that's preparing them for this kind of future?
I distinguish a lot between managers and leaders, right? And I think that a lot of us, we were managers first. We managed large teams, we managed large organizations, and we came into operational roles and other leadership roles through management track. And so if you look at the management track and how you became a leader through management track, you were never really trained to be a leader. But to me, leaders are people who have vision. Leaders are people who inspire. Leaders are people who have deep subject matter expert and knowledge, because they can gain the respect of their team and be transparent as they lead organizations. And I think that when you are a leader, your craft, what you're really good at, becomes very important, because people read that, people see that, right? And they look to you to set the direction, to get the customers to be proficient in your area of expertise or whatever, and to have credibility when you talk to your customers, because leadership is a public stage. And I always say that, you can't fake it when you are a leader. You just really have to be out there, and the people are going to either respect you as a leader or not respect you as a leader. And the people will always respect you as a leader when they see that you are able to lead, not just manage. Management is about just keeping together the operational aspects and dealing with your roadmaps and making sure that your deliveries are happening. We do need the managerial aspect, but I think leadership is directing and taking and going into new territories and opening new grounds and leading people through their fear of adoption of new technologies and new markets and new businesses that operate. So I do think that, I spend a lot of time trying to make sure that despite my leadership and despite where I am leading these organizations and folks, I have spent enough amount of time making sure that I'm relevant in my industry, and relevant because I was a practitioner, always is a practitioner, will remain a practitioner. I get, and it's about participation. It's about how you participate with your teams, right? I am not afraid to discuss hard problems. I'm not afraid to discuss, get into the code if that's what it takes. I'm not afraid to have deeper conversations around things and just really look at trade-offs and pros and cons. It's not a narrative that we're trying to fit into. It's more leading the team. And I think that is the future leaders would have to hone in on that, right? You can't be a manager and lead a company. You'd have to really step into leadership in a different way than you have in the past. In the past, you could be a manager because you're very well liked, or because you're very much renowned within the organization, or you spend a lot of time in the organization. Many reasons why you are stepped from a manager role to a leader role, right? But I think true leaders will eventually be leading the organizations, and people would want to work for them, because a title does not make a leader. Titles do not make a leader. I think that if you have to really be a leader, it is beyond title. Your ability to influence the people, and you've secured the hearts of the people working for you. And the hearts of the people, when you secure the hearts of the people working for you, they work for you at all hours of the day, because they're so passionate about your mission. They're so passionate about what you do. And it goes the same with me, right? I work all hours of the day because I'm passionate about what I do. So it translates all through your leadership, and it translates all through to the team members. So that's what I believe in. I totally believe in the fact that title does not a leader make, but at the end of the day, the people determine whether you are a good leader or not.
Well, thank you for being a leader on this public stage. And if someone wanted to find you, where would they be able to do so?
Well, they can look me up in LinkedIn. I have my email right at the top, george.janet@gmail.com, and also Intel. So you can email me at Intel as well. And I would love to be of value.
Thank you very much. It was very informative, and I do appreciate the time. So thank you.
Thank you. It was a pleasure talking to you.
It was a great time. Thank you.